and talk about some programming structures. Now remember, I don't expect everyone to be a programmer, but I do want you to understand what this particular lecture is all about. This deck goes over some of the constructors that you're going to want to be familiar with on the test, right? It's also tied to the 14xx protocol slide. So if you haven't gone back and reviewed that yet, do, because we're going to be reiterating some of the data in that deck is back. I don't expect anyone to be a programmer. That's not what this course is about. But I was really surprised to find programming questions on my version of the test. So I want to make sure that you get that benefit, because none of that was in the original NFT blockchain software or course content that I had. So this is really more about making sure that you are absolutely ready for that test and you can pass it with flying colors. Now, one of the biggest things that you're going to learn about is called a constructor, right? Now, in Solidity, it's a function that's used to initialize state variables in a contract. All right, a constructor is called when the contract is first created and is used to set the initial values all the way across the board. Now, the neat part about this is that constructors can be shared between a parent and a child. Now, what that means is that you actually have a really interesting opportunity here with constructors that are built correctly and in the right order to have a master contract shipping coffee to Seattle's roastery. So I would have a child contract for Juan, who Juan is going to get my contract on board that, or going to get that coffee on board the ship to Seattle to the roastery. I can have a child contract for Juan and a child contract for the shipping company and a child contract for offloading and trucking, and then a contract for getting it to the roastery. Because if I have a well-built main contract, I can use that contract as a template, because it will have all the initialization strings that I need to have, and all of my child contracts will have the same thing. So I have a main contract I use as a template, one that's been fully audited by a lawyer, one that works brilliantly, passes all of the security and QA checks, and then I've just got to copy it over to a child contract. So constructors are amazingly good to have inside of a contract, because now you can build templates. Now you can build components. Now you can do a lot of other really neat things with your contract that you can't do without them. Now, these can be called by what's called direct initialization or indirect initialization, and they look really crazy easy, right? So we declared a variable, string, right? String str. And now we're going to make a constructor out of that string. So we set a value of str to be a thing. So we'll make a constructor and we'll make it public, which means anyone can get to it, right? And then we'll say str is the string I'm learning programming. And that's all it is. That's all you do. Any one of your variables gets turned into a constructor, means I can now share them among other contracts or do other things with them in child contracts. It's neat. It's just a nice way of being able to have one set of variables that are shared among multiple contracts as part of that set. Now, we talked about variables. Our variable str we changed to I'm learning programming. Now, a variable is just basically a placeholder for the data. Whatever that data is, whether that data is a date, let's say I needed Juan to get that coffee to the boat by September 1st, then that would be a variable. If Juan has to do a thing or something else, whatever can be input, read, or written at runtime is an input. And in a smart contract, that can be as simple as a proof of something actually happening, some trigger event, so that the payment goes out and the cash register goes to chain. Right? Now, variables allow users to get and change the stored information. Right? So if I had a waiting for event to happen and that event was 0, right? No. And then that event happened, I can change that did event happen to yes or 1, and then make the cash register payout. So we're pretty good to go. Now, variables should never use a reserved keyword. There is a whole list of keywords for every single language that are reserved. So like pragma, one of the first lines in a Solidity contract, you don't want to use for a variable name. That's it, right? And then variables can start with an A or a letter A to Z, underscores, caps, no caps. It's really, really, really specific. If you have something with caps in it and something not with caps, those are two different variables, or numbers 0 to 1. So there's some examples here. We want to make our payment to one payment underscore shipping payment doc via delivery. My idea on variables is to make sure that they're totally understandable. So that means variables should be descriptive at least, right? So one payment, that makes sense, especially if I know who one is. Try to stay away from secret internal speech for your company, right? Now, one payment and one payment, caps and case sensitive, those would be two different variables. The fun part as a security person is if you see where they didn't pay attention to case sensitivity. So, and I may end up with two different variables. One that's one payment, did something happen, but I call the wrong one payment out. So we make sure if you do use something like this, that you are in your code following the same examples that you need to for your variables, because they are really truly case sensitive. Now, there are three types of variables: state, local, and global. Now, state, these are permanently stored in the contract storage. Each function has its scope, the things it can do, the things it can't do, and they should always be defined outside of that scope. Right? Local variables, these are just things I need until the function executes. So did one actually happen would be a local variable, and then we just use that to store temporary values because one is either going to ship or not ship. If he doesn't ship by X date, then I get to go do something else. I'd probably go to a state variable, and that will tell me what I'm going to do with it. The other one is global variables, and these are kind of special. They can be used globally and give information about the transactions and blockchain's properties. Right? So those would be the ones that would go into the master contract. These are things that you would definitely set. State and global variables would definitely go in your master contract. Local variables, some state variables would go into your child contract. Operators. These are things we do math here, right? Math, relational, logical, bitwise, all the things that you would otherwise do. It's just really simple Boolean logic. It's not really rocket science here. We're all really familiar with math, whether we love it or whether we hate it. Addition, subtraction, multiplication. You may do modulus. You may do increment, right? Especially if you have something going on. You may decrement in case something happens. So there's ways of doing math inside that contract that will make your life a little bit easier or a little bit more complex. Relational, this is important because if you have a trigger set on a specific date or you have a trigger set on something else specific, then you would want equal or not equal to or less than or greater than. These are all things that we use on a regular basis in terms of programming, in terms of information security and everything else. So you should at least know some of those. Logical operators, logical and, ors, or nots, returns conditions based on whether they're true or false or not true or not false. So basically a logic gate. Bitwise. Now these are interesting because we're actually Boolean working on an operation as part of an argument or part of something else. But they're all going to be an integer argument. They're all going to be math. Now, whether you use these or you don't use these in a contract, that depends on your programmer. But if you see these, you know that and lines greater, or the little caret, and all the rest of them are what's called a bitwise operator. Assignment, these are actually also really easy. Now, they're a little bit different than what you get with your relational, right? So your relational is equal, but in your assignment, you only have an equal. Again, A is equal to 21. That's it. I'm just assigning the value of 21 to A, and we're going to call it. Now we can add those assignments and subtract and multiply and divide. So you can do things with those assignments as you kind of go through. If you are reading in data coming from a keyboard, if you are reading data coming in from another program, you can actually then use assignment to turn that input into a variable that you can then multiply, divide, do whatever you want to do with. Now, conditionals are a little bit more interesting. I really wanted to use an example of that. So, unit, unsigned integer, you'll need to know that one. UINT is an unsigned integer. And basically, is the result is A greater than B or A equal to B or B minus A? Depends on what happens. You return that result and then something happens, right? So you really want to make sure that if something is true, or false, or bigger, or smaller, or greater than, less than, that you're using that kind of process on it. Now, arrays, and these are interesting. Arrays are basically data structures that group elements of the same type together. So going back to our box of chocolates kind of idea, a box of chocolates is an array. And inside that box of chocolates, you lift up the lid and you see a little map that tells you what each one of those chocolates means, right? So you can have the same concept, the same things. You would have a box of chocolates would be an array. A block of text would be an array. A block of numbers would be an array. You can have multiple arrays of the same type, but you just declare one array of the needed size. You store all your numbers, all your letters, all your chocolate, in whatever array you've got. There are two kinds of arrays in Solidity, static and dynamic. It's common for arrays to have what's called a contiguous memory location. That's going to happen inside of memory unless you are specifically telling it where to go, which is a bad idea programmatically. The lowest index, the lowest number, 0, 0, representing the first element, and the highest, 65,000. 65,000 is the highest, will represent the last element. You should let the computer do this for you. Don't try to do this on your own. Just know that 0, 0 is going to be the first one, and then you can do an array traversal in programming. Now, I mentioned that there are two kinds of array types, static and dynamic. Dynamic is the preferred because it's not a predefined size when it's declared. It will always be the right size that it needs. Static is predefined, so the total number of elements is going to be however big the array is. The problem with that comes along in is that if you need a bigger array than you actually initially designed for. So you definitely want to go with dynamic arrays rather than static. And then finally, mapping. So mappings are similar to hash tables or dictionaries in other languages. Basically, you have data stored as key pairs, with a key being any of the pre-built data types. So you could have a key pair for EVM, and then you'd have the other half of the key pair would be a number. So it can be any data type, it doesn't matter. Now, these are usually used to associate unique Ethereum addresses with value types. So my unique Ethereum address, 555, would associate with being a peer-to-peer node, or my number 444 would equate with being this contract type, right? So as long as it has a key value and whatever it is supposed to be, you can use it. You could use that mapping for legitimate addresses if you needed to or you wanted to, right? So a mapping would look like this. So contract mapping, we create a person, right? We give that person a name, a subject, and then marks, and that is unsigned integer 8, so 8 bits long, right? Then we would map address to person, and then address to public person as a result. That's essentially all it is. Just maps one data type to another data type and make sure everything works the way it should. Then enums. Now enums are a little bit weird for me, at least, because again, we're creating user-defined data types, and it's usually to provide names for integral constants. So I don't expect you to understand that or know it. But the big clue here is that enums restrict the variable with one of a few predefined values, all right? And these are part of an enumerated list, right? So options are represented with integer values starting from 0, and a default value can be given for the enum. So I could default and say my enum is 1, and I have a list of 0 through 8. So as long as it all meets what we need it to meet, but we can actually use user-defined data types. Now this can be kind of dangerous because you don't really know what that data type is or what it does or if it's valuable, but you're also going to use it. This is a really standard programming trick to use, so not a big deal there. And then finally, struct. You saw me bring up struct in this one. You saw the struct person. We're making a structure of a person, and we're saying that that person has a name, a subject, and marks, right? And that's essentially what it is. It allows you to create more complicated data types, so we have a name person, but person actually has a name, an address, a phone number, and they're useful for grouping related data together. Now that can be coffee makers. I could have a structure for coffee makers, and one is just one of many coffee growers that we have. I could have a structure for shipping, and one of many shipping companies. And it's just a really nice way of grouping related people together, or related items together, and it's really kind of a cool process to use if you get the opportunity to. Now, these can be declared outside of a contract. These can be imported in. Basically, to define a structure, you just got to give it a keyword, person, and then create the data type around it. This is done all the time. So in summary, right, the big thing you want to know, Solidity is just like any other object-oriented language. It has constructors, variables, operators, arrays. Really understand what arrays are and that they have them, mappings, enums, and structs. So this should get you all kind of set over on just some Solidity programming structures. Again, not meant to be a Solidity programming, but you really definitely want to know about things like arrays. Outside of that, though, I will see you in the next lecture.